Okay, students, today we're going to do the dot product, no relationship to yours truly. And the first thing is, here is what it is. If you have two vectors, here they are in the first one's in its component form, and the second one's noted in its component form. If you have those two, the dot product is taken by taking the first terms, multiplying them together, and adding it to the second two terms. Second meaning the second place one in each one. And if that reminds you of matrices, it very much is. So let me show you, only I think it's easier when you look at it that way, matrices. When I look at the big thing, anyway, I won't talk about that. Bad memories. All right, here we go. So how do I find the dot product here? Well, I'm going to take this first 4 times that 2, and I'll get 8. I'm going to add that to this product of 5 times 3, which is 15. So the dot product here is 23. Now, if you noticed, hopefully, that I multiplied a vector by a vector, and I got a scalar, I just got a number. I no longer have a vector. I just have a number. So please remember that. Let's do it again. On this one, if I take 2 times 1, I get 2. I add to that -1 times 2, and I get -2, and those added together equals 0. So yes, you can get 0. As a matter of fact, what's happening here, look at those 2 points. They're actually perpendicular to one another. So that's, when you get 0, that's what's happening. Okay, how about this one? 0 times 4 is 0, plus 3 times -2 is -6. And now I'm getting a negative number. Is that okay? Yes, it is. It's fine. But please remember, when you do this dot product, you don't get another vector. You just get a value, period. All right. Or instead of period, should I say dot? Get it? Haha. Okay, so here are the properties. First of all, it's commutative. Let me write that down. 1 is 0 times some vector is still 0. So the zero property holds. Okay, here, if you take a vector times 2 vectors added together, it is the same thing as distributing the u times v plus u times w. So it's distributive. That property holds. And this to me is a no-brainer. Of course it's like that. If you take a vector times the same vector, you're going to get the square root of the magnitude. Let me explain. If I had 4i, let's say plus 3i, because that'll be easier. 3j, excuse me. And I was looking for the magnitude on this. It is 16 plus 9 is 25, and the square root of 25 is 5. Well, if I did that twice, if I multiplied that by itself, I'm going to get 25, and the magnitude is 5. So anyway, to me that goes without saying. On this last one, I want you to see that if you have a vector times 2 other vectors that have been grouped together, you can rearrange that because it's associative. Sometimes I'll multiply the 2 easy ones first and then grab the third one. So what is the point? Well, the point is to find the area between 2 vectors. And we haven't gotten there yet, but you have to be able to do this first. This should be fairly easy, I think, if you can just remember. Some of this gets tricky down here. And so I'll give you some different problems to kind of practice with, but that's it. You guys take care.